Hello, students. Welcome back. We're going to talk more about planets and moons. This is from the Discovery Education Textbook, and this is from the Explore tab, number 1. So, what are the characteristics of planets and moons? I want to point out again that if you really think something's important, that you can actually click on it here and you could highlight it if you thought that was important, and you can also get it to read the text to you, whatever you highlight. So let me see if I can do that right here. And it's not
A star is
there
a
it is.
very.
Okay. And so we're going to get started. So in astronomy, that is one of the oldest sciences. And basically, astronomers study everything in the atmosphere. It can be um, planets, moons, stars, constellations, nebula, eclipses. They are looking at dust and black holes and just the most amazing stuff. It's just really awesome. It does involve a lot of math because to make predictions about something so far away, they have to use a lot of calculations. So stars are basically really large, and I love them because they're giant nuclear explosions, basically, fusion reactions that are up in the skies, and they're giving off a lot of radiation. Our sun can actually burn your skin if you're really pale like me. You get burned pretty fast. Our sun can actually burn your skin because it's actually like radiation out there. And as it comes down and interacts with your skin, it can actually cause you, if you don't have much melanin like me, to get a burn really quickly. And even if you have a lot of melanin, it can, you can get a burn over time. So, but at the same time, it's this great energy that helps, drive a bunch of life processes like photosynthesis that helps plants to grow that run our whole ecosystem. So it's an awesome energy source for us. But the solar system is very big, and our sun is at the center of it. And um, what holds everything around the sun? It's actually gravity. And why don't objects get forced into the sun with the gravity? It's because they actually have a sideways force too that is pulling them off like straight to the sides, and other objects are actually acting on um, gravity with them, like combining gravities. And so we're all kind of set in the solar system right now where we are. We're not getting further sucked into the sun, but there are these forces. An orbit is basically a pathway that goes around. It can be round, it can be egg-shaped, but basically it will hold an object rotating around another. And that rotating object is basically called a satellite. So our moon is a satellite of us because it rotates around us, and all the satellites that we shoot up into space are satellites around us, and we are sort of like a satellite around the moon, or around, excuse me, the sun. So other objects that are going around the sun are planets, dwarf planets, moons, asteroids, comets. There's dust. There's all kinds of things that are going around the sun. So when people make um, measurements in space, their main unit of measurement is actually called an astronomical unit, or abbreviated, I'll kind of highlight this, is an AU. And I have a short little assignment for you to do on AUs that will help you understand it. But just like all things, scientists had to come up with, well, what is one AU? And so they decided to make 1 AU, the distance from the Earth to the sun, is 1 astronomical unit. So how far the Earth is away from the sun. So as you know, it's really, really, really far. I think it's something like if you were traveling at the speed of light, it's something like 8 minutes away. If you were going at the speed of light, it would take you 8 minutes. In other words, if the sun burned out right now and burned out, we wouldn't actually know till that last bit of sun reached us for 8 minutes. So, anyways, it's a really long distance. Well, Neptune, which is our furthest planet from the sun, is actually 30 AUs. It's 30 times the distance we are from the sun. So, another unit of measurement is called a light year. And a light year is how far light can travel in 1 year. And that is really, really, really far. In fact, it's so far that I don't really have a good concept of it myself. It's almost like such a long distance that it's almost hard to wrap my brain around and really think, other than it's, how far light can get in 1 year. It's hard to almost imagine how far light could get in 1 year. But I can tell you that in about 8 minutes, it can get from the sun to the earth. I think it's about 8 minutes, and somebody can go look that up and fact check me and let me know for sure. But it's something like that is 8 minutes. And so, how far could it get in a year? The moon uh, is an astronomical body that basically goes around another usually larger body, and on Earth we have one moon and we call it Moon, right? It gets the special name, we call it Moon. But other planets also have moons, and many of them have lots of moons that follow them around and orbit around. And the moon, just like we are getting no closer to the sun, the moon is getting no closer to us. Well, we used to have 9 planets, and you probably have heard of this before, but you probably don't have a concept. Probably people about my age, some of the older parents and grandparents, they know when Pluto was a planet, considered a planet, and are kind of old school like that. I was sad to see Pluto get dropped from the rank of planet. But basically, in 2006, the International Astronomical Union basically said, hey, we have these things called planets, and yet we've never actually like defined them in that we have a criteria, like a checklist. So when they made that checklist, Pluto no longer fit. And there was essentially a planet named Aries that got it kicked out. So they discovered Aries, which was actually larger than Pluto. And they said, wait a minute, if this thing exists and it's larger than Pluto, then we need to come up with this checklist. So here was the checklist. They said for an object to be a planet, it has to orbit the sun. Okay. Then it has to have enough mass, enough size that it will kind of take a round shape, or an almost round shape. And that has to do with the gravity, and we will actually talk about that later, about why that would happen. And then it had to have cleared the neighborhood. That means like the pathway that it travels. It has to clear the general pathway that it travels of all the other debris. Well, that's where Pluto got kicked out. Pluto got the boot over that one. And I actually have a cool little video we could watch for a minute here on that. But before we'll watch that quick little video on Pluto, and then we'll go over a couple other little things.
Today's topic, Pluto, was discovered in 1930, the only planet in our solar system to be found in the 20th century. It is also the only celestial body ever to lose planet status. In 2006, Pluto, named for the Roman god of the underworld, was reclassified as a dwarf planet and given a number, 134-340. The discovery of the ninth planet captured the imagination of a world caught in the grips of the Great Depression. Finding a new world in space renewed our own world's faith in science. Its name was suggested by an 11-year-old girl from Oxford, England. She liked the fact that the first two letters of Pluto were the initials of its discoverer, Percy Lowell. Before long, even superstar Mickey Mouse had named his dog after the new planet. But by the 21st century, astronomers had come to the realization that the outer solar system holds many similar objects to Pluto, some even larger. With discovery after discovery of new heavenly bodies, the International Astronomical Union, for the first time ever, set out to define the word planet, and Pluto didn't make the cut. They decided a planet must orbit the sun, have gravity strong enough to keep itself in a spherical shape, and must have cleared other objects from its orbital neighborhood, making it the most dominant body in its immediate area. On the third count, Pluto fails. Pluto orbits the sun along the inner edge of the Kuiper Belt, a field of icy meteor-like objects located at the outer rim of our planetary system. Only discovered in 1992, astronomers have since confirmed the existence of at least 1,000 Kuiper Belt objects. Pluto, the ex-planet, is neither alone nor unique. Eris, a dwarf planet, is more than 25% larger than Pluto.
Okay, so that kind of shows little Eris knocked Pluto out of the running for a planet, but in some of our minds, it'll always be a former planet. um, so some of the other cool pictures in here that I wanted to show you are just the size of the different planets compared to each other. Look at the Earth. I mean, we're respectable compared to Mercury and Mars, and even here's Pluto. Don't you think that's funny that they just said it's not a planet and it says size and scale of the planets? You're still going to find some mistakes like this with older pictures. You're just going to find that. So watch out. And then look at these right here. And then look at them compared to like Saturn and Jupiter. Wow. And then compared to the sun. Look at that. Such a big difference in size. Another picture that I thought was really cool is this one that shows one astronomical unit for the Earth, and 5.2 of those is how far Jupiter is. So this is 5.2. Do you guys remember how far I said Neptune was? Neptune is 30 AUs. So if this was 5 units, astronomical units, and Neptune is 30, that would take it like way off your screen to show you how far out Neptune is compared to the Earth. Such a big difference. Okay, I'm going to end there for now, and then I'll come back and talk a little more about nebulae.